What transports oxygen inside your body?
Just your blood?
Yes, more specifically, there are things inside your blood. They start with an H.
Red blood cells?
Red blood cells,
Okay.
right? Hemoglobin.
Okay.
Okay?
Oh, yeah.
On the hemoglobin bus, this is a biconcave shape, so it's this little, like, almost figure eight, sort of a dishy thing with a little divot, right? On this, there's only 4 spots on the hemoglobin bus for oxygen, right? So 1, 2, 3, 4. Every one of these can carry 4 molecules of oxygen.
Right.
That's it, right? So what we have in people that are anemic is you have to change. There's a shift in iron here, right? So you basically change from ferric to ferrous iron, and it'll let that oxygen get off, right? So the problem is in people that are anemic, well, there are many reasons for anemia, right? But specifically, the people that the oxygen can't get off, this is just, you just need to change this. You just need to flip that switch and go, hey, get off the bus. Hey, get off the bus. And then the carbon dioxide gets on the bus. So if you have low oxygen, you have like this brain fog, right? Where's the oxygen go that your blood comes in, goes into the heart, right? Goes through the lungs, comes back, and then what? First stop, arguably, there's a branch that goes down to your stomach. I get it. Don't argue with me over simple things. First stop basically is the brain, right? So when you have this deoxygenated blood returning to the brain, oh, that's bad, right? Or if the oxygen molecules won't get off the hemoglobin bus, that's bad. That's not cool. So that's kind of the stuff that we're trying to fix. So that has a lot to do with the brain fog, post-COVID brain fog that we've been working on too. So there's a lot of stuff going on in the human body. So
I'm sorry, I have a question.
yeah,
When
this is what this is about.
When it flows to your brain, and you're saying the carbon dioxide is released, right?
Right.
So is that causing different brain injuries, or just the brain fog? Like, could it create
No,
something severe?
why is the carbon dioxide released? Because carbon dioxide is the natural byproduct of oxygen metabolism, right? So when you go through this oxygen metabolism, each cell goes through that adenosine diphosphate, adenosine triphosphate,
Right.
adenosine diphosphate, right? You go through that whole cycle. It spits out energy, but it also spits out carbon dioxide.
Right.
So the hemoglobin will carry that away as well, which is good. But it has to have the oxygen get off the bus first so the hemoglobin can get on the bus, right? So, okay. Now, like I said, there's many reasons for anemia, and hyperbarics doesn't cure anemia. Hyperbarics doesn't cure anything, right? The only thing it does is it'll put a Band-Aid on the anemia. Like I was talking to Kama earlier, I can fix the anemia by giving you more oxygen. But that's not going to help your anemia, right? It's going to fix it and put a Band-Aid on it right this second, but you're still going to be anemic when you get out of the chamber, right? So, you got to look at things like that. How do we do it? And the way that I teach the med school students, the way that I teach all the students, the doctors, on how to get through understanding how hyperbarics works is I teach them the mechanism of action of hyperbaric medicine. And when you teach them the mechanism of action, then they can go, I can apply this across a broad spectrum of diseases just to figure out which one's going to fit, right? Because we're scientists, right? We just want to figure out how it's going to work better. And you can go, what's the mechanism of action? So what's the mechanism of action of this thing, right? I'm going to take this pill, whatever it is. Pick a pill. I'm going to take that pill. What does it do? Oh, it vasoconstricts. Oh, it vasodilates. Oh, it does this. Oh, it does that. Oh, it ameliorates pain. It whatever it does, you can use that to your advantage. So that's the way I teach hyperbaric medicine, so that they can get a good handle on it.
Really interesting.
Make sense?
I like this topic. It's a lot.
Isn't it so
it's fascinating.
fascinating?
Man, I should have gone to school for science.
You can. You